Hi, I'm Pete, CEO at Elemental. I wanted to welcome you to the event today. Today we're going to be talking about an important topic, managing complexity. I have a great quote here from Brian Kernighan about complexity, and he says, "Controlling complexity is the essence of computer programming." Now, if you're not familiar with who Brian Kernighan is, he's a very smart cookie. He co-created the Unix operating system, which became the operating system underlying almost every device that you use, whether it's Mac OS, Android, iOS, Linux. He also wrote the book on C programming, which became one of the most popular programming books ever. And he also invented the idea of a Hello World program, which I think is pretty cool. So I think that controlling complexity is not only important in computer programming in general, but also in the art and science of data management and data engineering. And so let's talk about how this looks in practice. So a lot of us maintain these big, complex data pipelines that cut across a bunch of different, SaaS services, on-prem services, open source, and proprietary technologies. Now, they often run in different compute environments like Kubernetes, and they can also have a bunch of different schedules that they run on. So, everybody's got their own scheduler built in. They can run on different cadences, and then understanding how those schedules interact can be quite a challenge. Additionally, there are a bunch of failure modes that you have to contend with. So whether a step in your pipeline is simply failing because the service is down, or some services can be slow and your data can be late, or even somebody might be testing something in production and causing an issue. All of these can lead to challenges in your data pipeline. And one of the worst ones is when a human at the end of the line discovers a data quality issue and you have to go back and fix it. So there's a wide variety of fun and exciting challenges to solve with respect to failure modes. And compounding on this is that often every piece of your data pipeline is owned by a different person. And so there are different kind of teams you have to consult, and you have to work between teams to go figure out what went wrong and how to fix it. Oftentimes, this lands as a bunch of semi-frustrated Slack messages late at night asking why the data is broken or why the data is late or how can they do something in the data platform. And so we're going to talk about some strategies to mitigate this complexity today. The first thing we're going to do is we're going to talk to Pedram Navid, who's going to give us a 10,000-foot view of the problem. Next, we're going to talk to Yuhan, who's going to teach us how to think in assets. So rather than think in terms of the tasks that are producing and consuming data, we're going to center the asset in our thinking and see what that does to our ability to manage complexity. After that, we're going to hear from Odette, who's going to talk to us about integrations, specifically our DBT and Duckdb integrations. And finally, we're going to talk about partitions, backfills, and resources, and Tim is going to fill us in on that topic. I think partitions and backfills in particular are one of the most interesting problems to solve in data engineering, so I'm really excited to hear from him. Now, before we get to the content, I just wanted to plug our career site. So if you go to elemental.com/careers, we're hiring for a bunch of roles, and we'd love to hear from you. And with that, I'm going to hand it off to Pedram. Thanks.
Hey everybody, my name is Pedram Navid. I'm the founder of West Marin Data, a data consulting company. And in my line of work, I'm always finding that there's always a need for orchestration somewhere, whether it's ingesting from some random bespoke API or maybe an ETL job that needs coordination with DBT, or just some random SaaS product that needs to have some sort of webhook or API triggered. I'm always in need of orchestration in my pipelines. What I found though is data orchestration is often pretty hard in that I'm using different infrastructure for my local development than my production development. Maybe I'm using like a CSV to reduce compute usage locally, but then I want to use a data warehouse or a larger data set in the cloud when I'm pushing to production. I find that in the end, nothing ends up working the way I kind of expected. And as much as I'd like to, I just cannot ship my laptop. And so that's kind of what really drew me to Dagster. It was this idea that you could separate I/O and compute. It makes it really easy to build locally and ship confidently. Being able to think in terms of not just data assets, but like how everything is connected together, being able to see the materializations of all of that data, it's been really, really helpful for me. And so I set up this example as a demo. It has some of the common data patterns that I typically see in the line of work that I do. We'll pretend that we're like an open source software company, and maybe we're interested in some of the metrics on how we're performing in our packages. So Maybe we want to get some data from Python about our downloads and the different versions people are using. And maybe we want to get some data from GitHub about the forks and stars and all that kind of fun stuff. And ideally, we want to capture this data daily so we can trend it over time to see how we're progressing. On the Python side, I'm going to use BigQuery's really large Python dataset. It's a big public repository, very, very large. And so for local development, I've actually extracted that as a CSV so we can play around with it. And then on the prod side, we can run it against BigQuery, and that way we can avoid incurring large costs. On the GitHub side, I'll be using SteamPipe, which is a CSV or a CLI tool that can make it easy to interact with APIs. In this case, with the GitHub API. Again, locally, I'll just use a CSV extract to make things simpler. But then on the production side, we'll be hitting the GitHub API. Also in dev, we'll be using Duckdb as a database. That'll make running dbt really quick. But then again, when we push to prod, we'll just use that same BigQuery warehouse for everything. And once everything's all done and all the models are complete, in production, we can use Hex to sort of visualize that data as well. So that's the overall story around what we're going to be building today. I'll dive in now into a little bit more of the specifics of how this sort of DAG is orchestrated. Initially, we got the raw data coming in, right? So these are either the CSVs or the data coming in from BigQuery, either or, right? And then once we run that, we're going to do some processing. That's this intermediate asset right here. Now, in my example, there's not actually a lot of processing that needs to be done, but I included this as a way to show how you could take input data sets and maybe do something with it before getting that data persisted so that you can model it using dbt, which is what we've done here in the next step. I built out a dbt project, and Dagster has gone ahead and exploded sort of that model into these various assets, which is very handy. And then when all that is complete, I'm going to trigger a API call to Hex to tell it to refresh a notebook when I'm in prod. And if I'm in dev, it just won't do anything because my Hex notebook won't connect to my local laptop, right? So that's the overall architecture. What I'm going to do now is just go ahead and click materialize, and you'll see there's a partition range here. And because I wanted to collect this data daily, I've elected to choose partitions, which is a very nice way of being able to do things like, run a backfill if data is missing or incorrect, and just keeping track of how to run stuff daily, right? So here you can see everything's already been filled out. So by default, Dagster is not going to run it again because it's already complete. But what I'll do is I'll just say, let's run the latest partition, data for the last day, and I'll uncheck this to override it and tell it to run it anyway, even though it's already complete, and click launch. When I do that, you'll see the launch window comes up. We'll see our run, and hopefully if everything's working well, and now we should see, there we go, all of those assets getting materialized. And again, right now we're just in CSV land. We're using Duckdb. Things are going to go very quickly. The data doesn't actually change. It's just a flat file, so we won't see, the change in the actual downloads in GitHub stars. But for demo purposes, for building out and testing things, that's perfectly fine. And we can see it's all complete already, right? So far, so good. We're happy with that. And what we could do actually is start to pull in Duckdb and play around with some of this data that we have. So we'll go into the Dagster folder. There's a dbt project, and we can open up the Duckdb. And, we have a couple tables. We can go back to our overview right here and see them. We've got the base joined table, which just combines this data. And then we got the monthly, daily, and weekly views. So what we could do is just take our little query here and paste that in there. And voila, we have, some data. We can see it's working nice and happy. We can do the same with the daily data, right? And now we can see daily data aggregated. Obviously, all the numbers are the same because, again, we're just pulling from a CSV. But ideally in production, when we run this, the numbers will change over time, and we'll see that trend. So that, in a nutshell, is all we need to do on the development side. What I can do now is pretend I'm running in prod. So I'm going to quit Duckdb. There we go. And we'll close that. I will end my local Dagster session, and I will just tell it to run as if it was in prod. So that's an environment variable I use for my resources. And we'll give it a second, and it'll quickly come up. And I think it's ready. So we will refresh. And you can see nothing really changed except under the hood, we're now using the production resource instead of the dev environment. And if I try to materialize, we'll do the latest one again. And we'll click launch, not launch, and view that. We'll see it'll take a little bit longer because it's actually going to now hit BigQuery. It's going to incur a bunch of costs. It's going to read a bunch of data from GitHub, pull that all in, put that into BigQuery, and start doing the big number crunching that we love as data engineers, right? So while that's going on, I'll kind of show you sort of the ways in that this sort of materializations happen. It's kind of fun to take a look at. We'll look at the Dagster downloads here, right? We'll see it was materials as an asset. So we can click on view asset here. And here's like the latest asset. You can see a preview of the data, which is very handy. How many records, the row count, those two are the same thing. The name of the columns, what the query was that ran it, right? And you can track this over time with a plot potentially. And you can see, row counts go up and down. This is clearly when I was doing my test, and this is my production runs all on the same machine here. But that's overall how it works. And you can go back into any partition and kind of see how your data is working. So that's super handy. We'll go back to our run. Here it is. It's almost done. So all the data has been loaded. It's been created as assets in BigQuery. And now we're just asking Hex to refresh our data set using a new scheduled run. So we can just pull up our Hex notebook. And if I refresh, we should see a new run all completed right here. There we go. And here's that report. Here's that view. So it's pulling data in from BigQuery. You can kind of get a feel for the data. You can see we've pulled in some data on different days. You can see the trends. You can clearly see weekends versus weekdays in terms of downloads. You can see different project versions and all that fun stuff. So that's really Dagster in a nutshell. Let's say there was some missing data, for example. Maybe we thought that these 2 days were incorrectly downloaded. We thought there was a mistake here on the 15th and 16th. What's nice is you can go back into Dagster. We open up our job and we'll say materialize these 2 days because we thought they were, some data was backfilled incorrectly or something. And we'll uncheck that and click launch run. I'm not going to do this because it's going to incur a bunch of compute costs, but essentially you could click this and then it would recompute all that only for those partitions, which is super handy. Okay, so that's it. That's Dagster in a nutshell. Really useful for data analytics pipelines. Love the partition feature. I hope you can have some fun with this.
So, Pedram just shared an example of his analytical pipeline. As you saw, he's running the pipeline in Dagster, which gives a lot of benefits over just running cron jobs to trigger Python scripts. Now, let's go into the details about how exactly your analytics workflow can benefit from an orchestrator like Dagster. You also heard Pedram mention a few terms like asset and materialization. We'll get into them in just a bit. But first, let's talk about our typical analytics workflow. Just as Pedram mentioned, when I was doing analytical tasks, I also find myself dealing with lots of time-consuming and tedious data wrangling across so many different services. And I may sometimes get asked to pull data from a script that I made from months ago, where I couldn't recall anything, while looking at lines of Python code with often randomly commented lines. Sometimes I may even find duplicated versions of the same logic somewhere else. These scripts are often not well organized. They're not modularized to be maintainable, not to mention testable, and they may depend on data that are already outdated or no longer exist. In the end, you may end up looking at files like this. Remember this graph Pete showed earlier? Those unorganized files and services are often implicitly describing complex webs of data assets among hundreds of tables, notebooks, or dashboards that are powered by thousands of lines of code spread across a variety of technologies. This easily grows into chaos. You don't know why your notebook returns empty results, and you end up with conflicting analytical recommendations. You also don't know what to trust, and you may think you are analyzing with 99% confidence interval, but on top of zero trust data sources. However, Dagster, an open-source data orchestrator that focuses on building asset-centric data graphs, can make your life much easier. Dagster brings order to the codebase. With an orchestrator in your analytical workflow, your code gets versioned, tested, and a lot more maintainable. Therefore, it makes your data observable and trustworthy. Dagster also serves as a unified control plane. It centralizes all your business logics and integrates different technologies in one place with tons of built-in observability. Last but not least, Dagster offers smooth local-to-prod experience, which allows you to build locally and ship confidently. With Dagster, you can lower your mental load by focusing on doing your job and leaving other things to the orchestration layer. But how do we make all that happen? What makes Dagster different from other orchestration platforms? Dagster allows you to think in data assets when working with data. A data asset can be a table, a file, or a dashboard, anything you care about, the data itself. You may keep your tables up to date using an orchestrator, but most orchestrators just launch tasks. They don't know what an asset is. Dagster introduces a declarative approach, software-defined assets, to data orchestration. It lets you declare an asset you expect to exist instead of a task. In code, you define your business logic and the names of the upstream it depends on. Then, instead of asking whether an upstream task ran, you can now ask whether your asset is up to date. Dagster also provides built-in support for maturization, which means that you can simply persist the output of your assets to a table, a file, or anywhere you specify. Now, instead of describing the next step to run after one another, you can now write a definition in Python or load them from external tools like dbt and build a graph that shows all the assets for your use cases and use that graph to keep them up to date. With that, Dagster becomes the single pane of glass for your data stack, including all your sources and destinations, as well as how the logic flows between your data. It also centralizes your metadata in one tool with built-in observability, debugging, lineage, and cataloging. With all those built-in capabilities, Dagster reduces your mental loads of developing and maintaining analytical pipelines, and therefore, it turns the messy world that's full of unorganized code and heterogeneous technologies into a productive, safe, and happy platform. With all the benefits highlights, now let's dive into how you can quickly start thinking in assets and bringing your existing scripts into Dagster assets in just few steps. One of the key benefits of using Dagster is that it can help you transition smoothly from ad hoc plain Python script to prod-ready scheduled data pipelines. Let's take Pedram's project as an example. When dealing with analysis and large data sets, you would usually start simple like this. You first go to the warehouse console and download some sample data. Then a script like this would read the data from the local CSV file you just downloaded, parse it, and then build a chart out of the processed data to first make sense of the data before you go into deeper in analysis. To convert an existing Python function like this to a Dagster asset, it can be as simple as adding an asset decorator to your function, and then make it available in Dagster's entry point definitions. Then you can view the asset in the Dagster UI. Now, you may wonder how assets can be linked to each other. Dependencies between assets can be defined by adding the asset name as a parameter to dependent asset function. In this case, PyPy downloads will take raw PyPy downloads as its function input. Then, when you add both assets in your definitions, Dagster will understand the data dependency right away. Now, we've made it an asset graph. As we convert all the business logics over to Dagster assets, we've got a data pipeline that's ready to be automated. Dagster comes with built-in scheduler that allows you to schedule pipelines to be run at certain intervals or using other advanced scheduling policies. As Pedram mentioned earlier, he wants to get fresh data at minimum every day. We can easily schedule that here. We can build a job that materializes all the assets and then construct a schedule definition using that job. Now, let's switch back to the UI. We've got a declarative data pipeline that's scheduled on a daily basis. As we covered the basic transition from an existing script to a Dagster project, now let's talk about a few basic building capabilities that can make you more productive. First, have you ever got questioned by where does your data come from? And have you ever tried explaining all the caveats of your sources? When your assets are your business logics, as Dagster comes with built-in asset lineage, it's super straightforward to trace the origin and destination of your assets in the UI. Now, when someone asks, where does your data come from and where are they going, you can simply point them to the asset lineage view. Second question, your dashboard doesn't look right. Is your pipeline broken? Does this sound familiar? It could be a user behavior change or seasonality, but without spending a day or two diving deep into multiple services or execution logs, how would you know the answer confidently? Dagster comes with a rich metadata system. It allows you to annotate your assets or run with additional context. It makes it easy to respond quickly to questions like this by providing detailed information about the pipeline that produced the data or the data itself. Another common awkward scenario could be when you have a long-running pipeline and after a few hours of running it, it hits a typo. You likely don't want to run the whole thing over. Or when dealing with APIs with read limits or exploring large data sets, you might also want to incrementally process the data or be able to pick up from where you left. As we mentioned earlier, Dagster is aware of asset materialization, meaning it knows where your upstream assets live and how to load them even outside of the same run. It then enables incremental execution. With that, you can select certain parts of the graph and materialize just the selected ones, or just run your pipeline only on the data that has changed since the last run. Now, we've learned why you want an orchestrator in your analytical workflow and how to move from a plain Python script to a simple Dagster pipeline, and a few basic capabilities of Dagster that can benefit your workflow. I'm going to hand it over to Odette and Tim to talk in details about the features that can level you up to make your pipelines enterprise ready with engineering best practices.
Thanks, Yuhan. I definitely was one of those analysts too that had a bunch of different Python, Jupyter notebooks, and was never sure what version anything was, and different copies of different versions, just trying things out and working across a bunch of different tools. So speaking of tools, what I'm going to go through is showing you how to set up the Dagster DBT integration as well as Duckdb. So I'll dive into the code and show you what was behind Pedram's example. So first, just to go over, why would you use Dagster and DBT together? You might have everything working in DBT just fine on a cron schedule. So a couple different reasons. One is you're really visualizing the different DBT models, and you'll see them as Dagster assets all in one place. And you won't just see like one big DBT model, with everything involved. You'll actually see each of the different models and how they connect to each other and when they were less refreshed, and you really have a lot more visibility as to what's going on. Version control. So you might not know what I had one version of a model, I tested something out, now I want to see something else. I don't really know what's going on there. So once you're using Dagster, you could really maintain that and really maintain better code quality throughout your development process and know what's going on exactly in production. Other couple things are data lineage, so showing you from your Python API to another tool to a source system, what's going on, where are different things connecting to DBT and out of DBT, what is DBT dependent on, what's dependent on DBT, which of my DBT models are dependent on each other. So you're seeing a lot of different things there, as well as you probably not only have DBT and Dagster, but you could have a bunch of other tools, and Dagster provides a bunch of integrations, and you could really integrate with different Python scripts. So even if you're just testing something out in Python, a different transformation or a machine learning model, whatever it is, you could integrate with DBT and Dagster. Next is Dagster Duckdb. Why would you use Dagster and Duckdb together? So the first thing is you might have an existing huge database, but you don't really want to test things out and develop based on that because it's going to be pretty large amount of compute and you don't want to touch production data. You want to just mock something up. So Duckdb is really good for setting up local development, writing a bunch of SQL transformations, looking at your data, and really having that like local visibility, as well as when it comes to testing, you could actually set something up and don't really need to use the database. Now that we've gone over just high level what these integrations enable and what business value they'll actually drive and make your life easier, let's jump into the code and show you how to set these up. So what I have here is the Dagster project behind what Pedram was showing us actually in the Dagster UI. And you'll be able to set up this project either by looking at the GitHub repository, or you could also use the Dagster project scaffold if you're starting a new project, which will create a bunch of these folders like these setup files, as well as this PyProject TOML file. So everything you need for a Dagster project could be created with the Dagster project scaffold. So what I'm going to do is just show you what's going on in my DBT project. So over here we have this DBT project and we have 6 different models. So these are looking at GitHub stars, doing transformations with them, doing PyPy, combining the two data sets together over here. So if you see it, this is my SQL code that is doing the magic behind the DBT SQL query. So if we go into resources, so resources, the way you could think about it is everything that my data or analytics objects are using, so everything behind that. So specifically, let's talk about I/O managers. So what an I/O manager is in Dagster is an input and output manager. So if you're not using an I/O manager, you'll still be able to do a bunch of stuff with Dagster. And what it's actually going to do is, let's say you have a pandas data frame, it's actually going to pickle that data frame and store it in a temporary folder within this project. But what I want to do for this is set up a temporary Duckdb database so that I could set that up SQL off that locally and represent my data in that actual database. You'll see here we already have this BigQuery pandas I/O manager. So I'll show you how we could sort of toggle between local and prod and the code to do that. But for now, let's just set up what my Duckdb I/O manager is going to be. So if I just going to define this new Duckdb I/O manager and going to call it Duckdb I/O manager just for simplicity. And you can see here we already imported this Duckdb pandas I/O manager, so I'm actually going to use that. And then I'm going to configure it. And in that configuration, I'm just going to put first this that it's a database. And then I'm going to say where I want it to live, which I'm going to actually put it in this same directory as my DBT project. Okay. So just clean that up. That's actually all you need to do to set up and create this new Duckdb IO manager. And let's go through how it's used within our resources. So we have a bunch of other resources in here. These are actually going to be used by the standard Python Dagster assets. So I'm going to skip over them. And feel free to take a look at this repo and go through line by line. So here I have my resources definition, and what you'll see here is that this is a dictionary where I have local and prod set up. And what I'm going to do here is actually define what IO manager, what hex notebook, what even DBT project I should use while being in local and while being in prod. So here I have Duckdb IO, so that was the IO manager that I just created. And you'll see that that's different than prod. So in prod, I have this BigQuery pandas IO manager. And some of the reasons why you'd want to do that is you don't want to be messing around in your prod BigQuery just to test out some new things. You want to be testing it locally, seeing how everything works before moving to production. So testing is going to be really easy with this Duckdb IO manager and integration, and you also can feel a little bit safer that you're not going directly in prod and making sure everything's working before getting to that step. So I'm going to go ahead and save this, and then I'm going to go into my assets.py. So this is where all your different software-defined assets are going to be. And you can see here we already have a bunch of assets. So these are our standard Python assets, and what's going to be cool is that you're going to see how these relate to your DBT and hex assets. So everything you need for that analytics pipeline is actually all going to be in one place, and you'll have that visibility across the board. So we have this asset decorator. You'll see partitions in here. Tim's actually going to go through how those work in a little bit. So we could see all of those there. We also have a hex notebook asset over here. So that's going to control that notebook, and that's actually only for prod. So, okay, so now that we have a bunch of different Python assets in here, how do we get the DBT assets in? So what we're going to do is define my DBT assets and use the Dagster DBT integration. So this is going to be load assets from DBT project. So you can see that I imported that over here. And what I'm going to do is set up where the project directory is as well as the profile directory is. So let's put that in. So here I have the project directory and then the profiles directory. And that's actually all you need to do in order to set up your DBT assets as Dagster assets, or DBT models as Dagster assets. And so now let's see what this looks like within the Dagster UI. So let me save that. And right now I am just within this folder over here. And let's go to Dagster dev, which is going to run our Dagster UI for us. That just with that one line of code, all 6 of my DBT models now live in Dagster. Not only that, but I could see the connection points between the DBT assets themselves, as well as my different Python-based assets over here, and my hex notebook. So full visibility. You could also control these things. You could think of this as almost like a notebook in itself. You're thinking about each of your different boxes in your Jupyter notebook as one of these assets, except this is a lot more organized, and version control is going to be a lot less of a worry for you. And you'll know you're no longer jumping around Jupyter notebook cells wondering which one goes ahead of which. Okay, so what I'm going to do is just materialize a couple of these. I'm just running the latest partition. Tim will go over more details on this. So you can see that this is actually calling from the API call. So we're getting our PyPy downloads as well as our GitHub stars in here. These are doing some more transformations, and then we jump into DBT. So if I materialize these, I also want to just show you that how this Duckdb is getting set up. So if you noticed before, we didn't actually have this Duckdb over here. And now that we're running everything, it actually, Dagster spin that up and is storing things in that Duckdb database. Okay, so let's jump into one of these DBT assets. What does it look like? So right over here, we actually have the full SQL query, so we could really have visibility into what's going on there. We could also see just our different assets over here. So if I go into one of the ones that materialized, you'll see that we have the run. So if we had more runs, you could actually see all of those, know what went on with each one of them. As you have more runs, and this is going over more iterations, you could see plots, definitions, lineage, so you could really see where it fits in, upstream, downstream, seeing how everything connects over here. The next thing I want to do is just go over a couple of the other things within Dagster. We have schedules and sensors, so you could set this up to either be running every day at a certain time, or you could actually put freshness policies on your assets, and that could sort of think about, oh, I need, let's say, the sales data updated every day, but then my customer database, I only care to update it every Monday of every week, or every 7 days, whatever the case is. Now if we go to resources, we could actually go see that we have our DBT over here. So we could look at that and see where it's used. So this could be super helpful just to see where everything came from, as well as if we just go to IO managers, we could see that we have which one we're using. So we have this Duckdb database over here. If we were to change the prod, you'd see the big query come up over here, and we could see where it's used. So that's all for Duckdb and DBT and how they work in Dagster. I really hope that this helps you. You could see, when everything was updated. So gone are the days where your visualization, you're asking, oh, does this have the latest data? What data does it have in? Did it run this morning? This will really help you with that. Over to you, Tim.
In the previous sections, you learned about how the data analyst workflow can benefit from using an orchestrator like Dagster. Then you turned an existing script into a full-on Dagster project. Now we'll add a couple more features to this project that will improve your quality of life by making your analytics faster, cheaper, and easier to maintain. In particular, we'll cover how to partition your data and backfill your analytics pipelines by these partitions. We'll then top it off by implementing patterns for swapping connections to external services by using resources, allowing you to connect to different services during local development and production deployments. First of all, what is partitioning? Partitions are a way to organize your data into smaller chunks, which can be used to speed up queries, make data pipelines more efficient, and big data easier to manage. For example, in your project, you download GitHub stars and PyPy stats daily, and therefore you should only need to transform that day's worth of data and not rerun all data from all time every single day. By organizing data into partitions, updating individual slices of data, such as an individual month, location, experiment, or demographic, becomes trivially easy with what we call backfilling. Backfilling is the process of updating historical data. For many people, this has traditionally been done by deleting all previous data and rebuilding a data set from scratch. This can be slow, risky, stressful, and expensive. However, by partitioning your data, the backfill process changes, as now you backfill only the data that needs to be updated, rather than having to backfill everything every single time. Some situations where this is useful are, such as when issues with data quality were found in last month's data, and now you need to rerun all of last month's reporting. Or when business logic for a data asset changes and you need to update some data to reflect this. Here is how partitions help, and here are the benefits of it. For one, speed. You'll only be running data that needs to be run, meaning your analytics processes will be faster. Next up is maintenance. Updating the logic for a data asset or model is inevitable. Backfills in Dagster make updating historical data less stressful by making it easy to run just a few partitions at a time, or rerun a pesky partition without having to rebuild everything. And finally, costs. Since you're running only the data that needs to be run, your runs won't just be faster, but also cost less. For example, running this project regularly would exceed the limits of the BigQuery free tier. This is because it would rebuild the data every single day. However, with partitioning, a daily job would only ingest a day's worth of data, and therefore process a day's worth of data, and so would cost substantially less. Let's see this in action and find out how we can add partitions into our project. First, let's pull up the assets file. Then we'll import the daily partitions definition from the Dagster module. Then let's define a start date as to when is the first time we want to start ingesting data. Then we'll declare the daily partitions definition on the asset. Then we'll add this metadata for partition expression. This metadata tells the IO manager how to partition the table, such as which column to use to partition the data with. And then finally, let's go into the Dagster UI, reload our definitions, and see our asset graph now. You'll notice that some of our assets now have a slightly different look. Here you can see which assets have partitions, how many of those partitions have already been materialized, and how many partitions haven't been materialized yet. Let's click Materialize All, and rather than just immediately kicking off a run, you'll see that because certain assets are partitioned, you can now specify which partitions to backfill. In this case, let's backfill a couple days worth. Now when you hit Materialize, you will kick off a run and backfill to materialize your assets, including backfilling the partitions of your assets. Next up, let's talk about resources and connecting to external services. One of Dagster's core principles is to complement the workflow from local environments all the way to production. Now, an environment is the location, data, and situation that a pipeline is run on. For example, the local environment on your computer, or your production environment in the cloud that your daily reporting depends on. As part of that, Dagster has resources, which are a feature that lets you define how to connect to these external services. The perks of resources are that resources can be configured on a per environment basis. In this project, you've been using Duckdb. However, you can have it so that we use Duckdb locally and BigQuery when we are in production. The benefits for this are that you can run your data in a separate location without affecting production. This will also help you reduce the time to test a change to your analytics pipelines. And finally, once again, this will help save money by strategically using smaller samples of data during development purposes. Let's see how resources are used in our project. If you look at the overview page, you'll find the Resources tab. There, you can see what resources we've configured and what uses them. Now, if you flip over to the resources.py file, you can see these resources being made. You'll notice in this file this dictionary with two keys, local and prod. The local entry defines what the resources are during local development, while the prod entry defines which resources are used in production. For example, as mentioned, in local, this uses the Duckdb IO manager. However, in production, this uses the BigQuery IO manager, as defined here. Now, if we look at our definitions, you'll see that the resources parameter uses that dictionary we were just looking at. An environment variable is used to access the appropriate entry. Let's see this in action. If we look at our terminal output, you'll notice that we have been using local resources based on these log statements. However, if we temporarily turn Dagster off, change the value of that environment variable, and restart Dagster, you'll now see that it uses the prod configurations. Now, if we pull up the UI again, the resources and what uses them have not changed. But when you kick off a run, you'll find that it'll use the production resources, such as an actual SteamPipe instance, and connects to a BigQuery project, rather than that local Duckdb file.
All right, that's all the content we have for today. Thanks for coming, and be sure to check out our website at dagster.io to learn more. Thanks.